All right, everybody. So this is a little video just to explain one more time comparative advantage. Again, I apologize for making it confusing and not being particularly clear about how this works. So hopefully this little video helps you understand the concept a little better and work through some potential problems that might be in the exam related to comparative advantage and how important it is. So I'm going to start out by giving you a sample production possibilities for two people. As always, we draw our production possibilities by doing just a simple XY axis. And then on the X axis, we're going to do quantity of motors. Y axis, we're going to do quantity of radiators, abbreviated RAD. Then we'll do three little tick marks, three little tick marks. And then in blue, I'm going to do one line. It goes from the third tick mark to the first, and then a second tick mark, second line that goes from the second tick mark to the second tick mark. All right, and then we're going to make this 30, this 20, and this 10. 10, 20, 30. Okay, so in this economy, we're going to have two producers. We're going to have Monica, we're going to have Craig. And they can produce a maximum number of radiators or a maximum number of motors, or any combination in between. So Monica can devote all of her time and resources into producing 30 radiators or 10 motors, or some combination in between. Craig, on the other hand, can produce 20 motors or 20 radiators or 20 motors. Now, the first part of this question that I want to go over is absolute advantage. Apologize for any spelling errors in advance. So absolute advantage, remember, is just who can produce more. Basic, pretty simple. And in this case, unlike some of the other problems I've given you, we've got two different answers. Um, Monica has the absolute advantage in radiators. Why? Simply because she can produce more. Craig, on the other hand, has the absolute advantage in motors. Because he can produce more. Now, the frustrating thing about this is it doesn't really tell us anything about the cost of producing these particular items. It's one of the reasons why absolute advantage really isn't all that interesting for us, because ultimately these two people have different costs to produce, since they ultimately have to trade off between one good or another when they choose to produce. So that's where our old friend comparative advantage comes in. So let's make a little table. So we're going to do the cost of radiators for motors and the cost of motors for radiators. Okay. In this case, we could simplify this by just saying this is the, oops, that this is the cost of motors and this is the cost of radiators. Okay. So you're probably wondering, what does this all mean? Well, let's look at the math a little bit more. So let's start with Monica. So if Monica wants to produce motors, 10 motors, she has to give up 30. So 30 radiators for 10 motors. Now, this isn't particularly helpful for us right now in its current form because it's not simplified down to a common denominator. So what we're going to do is we're going to divide by 10 so we can see what her cost is for just one motor. So divide by 10, we get 3 for 1. So we'd say that Monica has an opportunity cost of 3. Okay. Now let's do the same thing on the other side. So she can produce 10, oops, one color. She can produce 10 motors for 30 radiators. Now, we want to see what her cost for one radiator is, so we divide by 30. What we get is 1/3 of a motor for one radiator. So what does this mean? In order to produce the resources she would give up would not for to produce one radiator would not produce one motor. So in this case, her opportunity cost for one radiator is only 1/3 of a motor. Pretty good. Ultimately, what we would say is that she has an advantage in producing radiators over motors. It costs her less to produce the radiators than it does for the motors. Only 1/3 of a motor compared to 3 radiators. Now let's do Craig. So, same dealio, 20 for 20. We're going to divide by 20, and it's 1 for 1. His production's symmetrical. He's multi-talented. He can really produce them at the same cost. Same deal over here. Divide by 20. 1 for 1. Okay? Now, let's look at who has the comparative advantage for each good. Okay. So, in the market for motors, we've got two options. Either we can produce at a rate of 3 radiators or 1 radiator for each motor. Well, ultimately, we would want to produce at 1. So, Craig has the advantage. In the market for radiators, we can either produce with a cost of 1/3 of a motor or 1. In this case, Monica is our preferred option. Okay, so you're probably wondering, why in the world does this matter? Well, it's pretty simple because ultimately these two could trade and have produce better outcomes for both of them. Now, this is one of the cases where absolute advantage and comparative advantage are the same. That will not always be the case. There's certain instances, like the one that we reviewed in class the last time, where, for example, um, one of our characters actually produced less overall than the other, but she still had an advantage in producing some goods at lower cost. So I don't want to foreclose that as the option. Just in this example, um, the two are the same. Now, let's say that Craig goes ahead and just puts all his attention towards where he has the advantage and produces 20 motors and 0 radiators. And on the flip side, Monica produces 30 radiators and 0 motors. and Craig trades 5 motors or 7 radiators. Now, these are what we call the terms of trade. Now, this is pretty important, and I'll show you why in a minute. But let's just say that he wants a few more radiators because for both of them, producing the motors is a little bit more costly. It takes more resources. They can only produce a maximum of 20. In Monica's case, you can only produce a maximum of 10. So it's going to cost a few more radiators to get one motor. So what does that mean? So let's do a little trade table here. And that's radiators and motors. Okay. So because she ordinarily would have produced 30, but she's giving up 7 radiators, we say that she has 23. But because she's trading, she gets 5 motors in return. Okay. And Craig, on the flip side, ordinarily is producing 20 motors, but he's trading 5. So he gets 15, but then gets 7 back. So we say he gets 7 here. Now, here's the question. Is this a good deal? Like, is this going to pass muster? Well, in order to figure that out, we have to do a bit of a calculation. And we have to go back to our old friend slope-intercept form. Okay. So this is a pretty simple calculation. So I can tell right off the bat, we do rise over the run. So 30 over 10 is our slope. So our slope is -3x. And our y-intercept here for Monica is 30. So y equals mx plus b. Okay. Now to determine whether she got a good deal or not, we're going to plug in our x here. You can do the y as well, doesn't matter. And we're going to see in ordinary circumstances, if she were to produce on her own 5 motors, how many radiators would she get? Y equals -3 times 5 plus 30. Y equals -15 plus 30. Y equals 15. Oops, 15. So ordinarily, she would only get 15 radiators if she produced 5 motors. But right now, she's getting 23. So we would say she has a gain from trade of 8. Just 23 minus 15. Now let's do the same thing for Craig. Y equals mx plus b. Y equals, let's go back up here, rise over the run. It's -1, pretty simple. Plus 20 is our y-axis. X, okay. And then let's do the same thing we did before. Let's plug in 15. Negative 1 times 15 is just -15 plus 20. Y equals 5. Okay. Gain from trade of 2. Pretty simple once we do it that way. Okay. Now the interesting thing about this, and I can just kind of tell you this on the side, is let's say that our gains from trade were 5 to 5, right? So 5 motors for 5 radiators. In this case, what we would find is that Monica would make out with some gains from her trade, but Craig would not. He'd be just at a net of 0, right? Now, the interesting thing is that we would still say that is a positive outcome because in total, in the economy, somebody has made out better. There's still been an advantage to trade. in this circumstance. It's just Monica has made out a little bit better than Craig, but he still is sort of meeting what would be his production possibility in the event of producing motors. Okay, so that's what I've got for now. As always, feel free to send me an email, send me a message on Canvas, or we can talk about it in class or during our lecture review towards the end of this unit. And I'm happy to go over this again. So hopefully this helps. Let me know. See you later.